Hey everybody, I'm Amanda with DevExpress and welcome to today's webinar, Functional JavaScript, presented by DevExpress CTO Julian Bucknell and DevExpress Technical Evangelist Paul Usher. In today's session, Julian and Paul will discuss writing JavaScript in a functional style. This session is being recorded and it will be made available on our DevExpress YouTube channel later today. We will also do a live Q&A at the end of this presentation. Just type your questions in the GoToWebinar control panel at any time throughout the broadcast. All right, thank you so much for joining us. I will now hand things over to Julian and Paul.
Hello everyone, I'm Julian Bucknell, and on the webinar with me today, as Amanda said, is Paul Usher, our Antipodean technical evangelist. Paul, are you there?
Good morning. I certainly am, an Antipodean. Yes.
I've been looking things up in the dictionary. There you go.
It's a good word for Australia and New Zealand.
Yeah.
Although I think today, Julian, it's going to be more about you and your JavaScript skills.
I'm afraid so. The one thing that I've done over the past few years is get really into JavaScript, and one of the aspects of JavaScript that a lot of people get worried about perhaps, or afraid of perhaps, is functional JavaScript, or writing JavaScript in a functional style. In fact, over the past couple of webinars, you and I have been talking quite a bit about DevExpress, coding up lots of client-side script, and every now and again, probably without pointing it out, we've touched on writing JavaScript in this functional style. Now, with this webinar, we're going to explore what that actually means.
So we're going to be talking about ifs and all those weird JavaScript terms like closures, lexical things.
Yes, indeed. We'll be talking about those. I'll briefly even mention currying just to whet everybody's appetite, as it were. So, yeah, but in essence, I want to get away from the academic side of functional and just basically introduce a very basic way of looking at JavaScript functions and how to use them and all that. Now, when you come from a C# background, as you and I do, and many of our customers on this call, JavaScript as a programming language seems a bit of a mess, a bit of a mix-up. There aren't even any classes, for example, although you can pretend they are there by squinting at the code in a peculiar manner. There's objects, yeah, sure, but they don't work in the same way as in C#. Variable scope works differently. There's a veritable paucity of primitive types. There's 6 of them, and 2 of which are weirdly enough named null and undefined. And this works in a different way, and then there's the functions. Now, personally speaking, I think once you get JavaScript functions in a sense of grokking them, but that will show my age, you can write some simple code very neatly yet expressively and highly testable, and this is what we're going to be talking about today. So the big thing to understand about functions is they are objects in JavaScript. If you want to be formal about it, JavaScript has first-class functions, or if you like, functions are first-class objects. You may also see, if you're surfing the net, and you see this academically, higher-order functions. No matter what term is used, it means that functions in JavaScript can have properties. You can pass them into other functions, you can return them from functions, you can store them in variables and data structures, and it's very different from methods in C#. Those functions are just bound to an instance of a class, or they're static methods, for example, and they're actually bound to the class itself, and it's really hard to manipulate them separately. Not so in JavaScript. Now, with functional programming, I've taken the advice of think verbs and not nouns. Classes and objects are more about things, their state and what they can do. Functions, on the other hand, are more about actions and doing stuff. And yes, if you do research this stuff, functional programming gets a little bit academic. So be not afraid of words like currying or memoization or arity. There's another good one for you. I would just say forget about it. Now, enough of the slides. This is all about coding. So time for some examples here. I'm going to start off with a nice traditional example to show you what I mean about those previous couple of slides. And I'm going to be using Sublime Text here. It's the one I prefer writing my JavaScript code in.
Julian?
Yeah?
Before we look at all the code, can you just give us a bit of an overview, maybe for clarity, as to JavaScript versus ECMAScript version 5, 6, and where things like TypeScript come into some of this stuff?
So the whole point, as I just said, with JavaScript is it's a bit of a mix-up. It was designed to be very flexible, and sometimes that very flexibility means it's hard to code valid software with it, and to test it, and to what's the word I'm looking for? To avoid unintentional errors, because after all, JavaScript is executed at runtime. There's no compiler for it. So with TypeScript, what happens is TypeScript is a way of adding a very C-sharp-like syntax to JavaScript, and there is, in fact, a compiler. It compiles TypeScript code into JavaScript code, and then you run the JavaScript code in your browser and all the rest of it. Another one is CoffeeScript. That was another variant, if you like, of a JavaScript-like language which compiles to JavaScript. Some people like that. Angular 2, for example, is actually written in TypeScript. They've embraced the whole classness of type safety of TypeScript to write Angular 2. Now,
with TypeScript, you end up with raw JavaScript at the end of it, right?
Oh yeah. You compile to raw JavaScript and you execute the raw JavaScript. Now,
so it's not replacing JavaScript.
Oh no. Now, of course, JavaScript itself is not standing still. There is the standards body called ECMA, and they publish every now and again a new variant of JavaScript, and they're starting to add new features to JavaScript, and we'll see a couple of those as we go through here. They're adding new features to JavaScript which will eventually make it into the browser, and some of these new features are in the browser already, and it means that JavaScript itself is evolving and becoming more, how can I put it, it enables you to write more better without some of the weird and wonderful bad examples of JavaScript code that you used to be able to write in the old days. So everything's evolving, shall we say. JavaScript itself, the ECMAScript 6 variant, browsers are starting to support various features in ES6. You can write your code in ECMAScript 6, and there are compilers which will compile it back down to JavaScript 5, which is what we all use at the moment. I'll be talking a little bit about that later on. So basically you choose your poison, I would say. How about that? If you don't particularly like JavaScript, then fine. TypeScript is a great language, it's a great way to actually get client-side code and write it, if you like, a valid manner very easily. Personally, we're looking at this particular bit of code at the moment. let me just explain what the code is going to be doing. I'm going to imagine I have an array of numbers and I want to find the sum of the elements in that array. Now, I'm sure everybody here could actually write this code very easily, and there is a couple of things to notice about this code that I've written. The first is these weird-looking comments at the top. This is my way of writing valid JavaScript. I use a linter program called JSLint to validate my JavaScript before I even run it. So it's like a static checker of my code checker. I've actually configured I've configured Sublime Text here to use JSLint. So if I save this file, what's going to happen is JSLint takes over, validates the code that I have in this file, and basically at the moment it's throwing up an error saying it's not expecting to see the word var right here. And that's because JSLint enforces you to declare all your variables at the top of a function, for example. So I'm just going to leave that here for now, but with JSLint what I do try and do is to remove all of these warnings. So here I am, I'm going to remove this warning right now by doing that. In essence, you're making it easier for a human to read the code, not necessarily for any interpreter or compiler to run the code in a different way. The second one to notice here is this statement here. It seems a little bizarre. I'm declaring a string as a statement and that's it. It's a special string. USTRICT means that this function, when run, will stop some nasty things happening by throwing errors. One of the nastiest things that it stops you doing is writing to the global object. JavaScript has this awful propensity for you to add things to the global object, and because it's global, it's available everywhere and you mess things up. So this is one way to stop that happening. JSLint will also throw errors as well, so this is just an extra level of prevention, if you like, from writing bad code. Now, also, I've configured a build system with Sublime Text so that I can run JavaScript with Node. I've got Node installed on this machine, and so I can basically run this code and we see the result of the code. I'm just using Node as a way of running the code without having to go to a browser and do all that. So in essence, this is a great way, Sublime Text is a great way, once you set these things up, to actually write some valid JavaScript and to test it and to make sure it works and all that. Anyway, back to the actual code. I'm sure it's pretty easy to read. It's a simple loop. Here we are. Here's the loop. We're adding up all the elements. I'm building a sum, and we're going to return the sum. And here's the code that's going to execute that particular function that I've written, and everything's very simple. Now, once you've written this, imagine you're in some my mind's gone blank, development department, IT department or whatever, and you learn that you have to actually calculate the variance of the values in an array. The variance is a statistical measure of how spread out the values in the set are from the mean. And the square root of it is known as the standard deviation, which you may have heard of. Now, the variance of a set of values has a particular mathematical identity, and it's this is one of them. The variance is essentially the mean of the square of the values minus the mean of the values squared, and this is the actual thing that you execute, calculate it with the algorithm, if you like. You sum up all the squares of the values, and you subtract the sum of the values squared divided by n over n. That's one way of calculating the variance. But notice we've already done this bit, the, oops, go back, the sum of the values, this is that code we just wrote, and here we have now the sum of the squares of the values. So let's jump back and have a quick look at how we'd write that. And it's pretty easy. In fact, all I did was copy and paste and change this line from the previous line. So if I go back to example 1, and you can see the, there we go. We can see just the difference here is this particular statement. That's all I'm changing. The rest of it is exactly the same. And in fact, if I execute it, oh, I'm on example 1 here. Sorry, example 2, I execute it, and the sum of the squares of the elements is 91. So what I've done here is I deliberately did copy and paste code duplication. Now, is there not a way to have a summation function with another parameter which actually defines what to sum? In other words, either array I or array I times array I, basically. Then that's what I've done in this third example. So here's my sum values function here. I've declared two very simple functions, one called getValue. What it does is whatever's passed into it, it returns. And the other one is getSquare. So whatever it gets passed in, gets squared, and that's returned. So I have two functions, both of which just take a value and return some other value. And then what I've done is, in the sum values function here, is it takes an array, as in the previous examples. Let me just show you example 2. It just takes in the array, as it does up here. But it also takes in this function parameter that I've eruditely called fn. Now in the loop, what we're going to be doing, here's the old loop again. And in the loop, we're going to add up the return value of sending the current element to this fn function. And everything else stays the same. We initialize the sum to 0, we return the sum after we've gone through the loop. The function that's been passed in here is traditionally known as a callback function, because that's how they were originally used, but we're not really calling back anything, we're just calling that function passed in. Now, at the bottom here, notice I've got my example array, and I'm actually calling some values twice. I'm calling it once with the getValue function, which just returns the value, and once with the getSquare function, which returns the value squared. So let's just execute that. And we get two answers. The simple sum is 21, and the sum of the squares is 91. So what I've done here is I refactored that code duplication into one function which does some summing, and what it sums is passed off to other functions which return some kind of value. Now, before moving on further, I want to emphasize a couple of points here. The first and most important is these two new functions I wrote are deliberately simple. They do one thing and they do it well. They don't rely on or modify, in fact, any external data whatsoever. They are completely side effect free. They are, if you like, pure functions in a mathematical sense. Given an input value, they will always produce the same output value. Hold on a moment, let me just make sure I've got something set up. Okay. I'm sure that you can immediately see how important this could be. First of all, they are much more easily testable. Second, given that the output for a given input is always the same, you could cache the results. Now this is important for those pure functions that involve a lot of calculations. You can save time by doing the calculation once and then reusing it. You save it, you reuse it. This process is known as memoization or memoizing. And since the function is small, easily readable and explicit, it becomes self-documenting. Now, take a look again at the sum values function. Now it's true, it also is a pure function. Its output is solely determined by its inputs, the array and the function. But look deeper. Its goal is to calculate some kind of value by iterating over all the elements in the array, where the calculation is going to be explicitly defined as addition. A fixed value starts off the calculation and the calculated value is finally returned. Now what if we wanted to calculate something else over all the elements in the array? Say the count of even numbers in the array. Now here's one way of doing that. I'm going to write a function that returns 1 if the value passed in is even, or 0 if it's not. And then we can just use the same sum values function as before. So example 4, here we have my little function. It takes the value, finds the remainder by dividing by 2, and returns, okay, if it's even, that's going to be 1. No, sorry, if it's even, this value is going to be 0, so it's going to return 1. And if it's odd, this value is going to be 1, so it's going to return 0. So, and I have exactly the same sum values function as I had before, and lo and behold, if I execute this code, the number of even values in this array is 3. In other words, 2, 4, and 6 there. That's all fine and dandy because I was clever enough, if you like, to express this callback function in a way that allowed me to do some kind of summing or addition. Now I'm going to break apart this sum values function a bit more. I'm going to pass in the initial value and modify the calculation that happens with each element by deferring it to some other function. So now we're getting a bit more interesting. Now take a look at calcarrayvalue here. It takes in an array, it takes in the initial value, and a callback function to call for each element. Now unlike our simple functions before, this one takes in the current calculated value, or accumulator if you like, and as well as the current element from the array. It increments this count by 1 if the element is even, by 0 if not, and returns the new value. So it's returning whatever I modify this count value to be. Again, this callback code is small, easily testable, easily readable. Now the calcarrayvalue function has now been reduced to an extremely simple loop over the elements. So it just has the loop. It calls this magic callback function passing the current value and the current element, and that returns the new value from calling this function, and eventually it just returns the value. Now, it doesn't even know, this calcarrayvalue method, function, doesn't even know or care what type the value being calculated is. All it does with it is it passes it into callback and it retrieves it back. It doesn't know what type it is. It could be a string. It doesn't have to be a number. It doesn't even know or care what type the elements are. It just throws them into this magic callback function again. So there's no external data or configuration being used or accessed either. It's just a pure function. In fact, this function is so important it has a name. It's called reduce, or sometimes it's even known as fold. It reduces an array to a single value. And reduce is present as a method on the array prototype already in JavaScript. So I can change that last example this is a nice example. I'll show you it works, by the way. The count of even values is 3. And I can change it to the reduce function, which is a method on the array type. And so I can, here's the callback, exactly the same as it was before. The reduce function takes the function to call for each element and the initial value, and it returns the final value. And lo and behold, it works. And finally, I've got rid of that for loop. Now, there's something else to note about reduce. It's treating the input array as immutable. The callback function doesn't even see the array. All it sees is the current value plus whatever array element is the current one. So the callback function can't modify it. And immutability is possibly the most important thing to try and grasp about functional languages or writing JavaScript in a functional style. Try and treat your data structures as immutable. You can infer much more about the correctness of algorithms and of code when you do that. Immutability is a goal to continually strive for. Let me just show you that. So here we have the num array thing here. So if I say consolelog num array before I before I call all this, and I do the same afterwards, you'll see that it's going to be the same value. I haven't changed this array at all. All I've done is count the number of even values. Now, let's explore this reduce function for a couple more examples. Another common task with arrays is to filter the elements in an array in some way and ignore some of the elements. So you're looking for some kind of important elements. You want to filter out the rest. Since we have our immutability hat on, we'll change that spec, if you like, to given an array, return another array containing the items we want and filter out the rest. The scenario then is this: a function that takes in an array and a callback function and returns another array containing the elements needed. The callback function will take an element and return true if the element is needed, or false if it should be filtered out. Now, if we had our old for loop again, we could do that quite easily. Here we are, here's our for loop. We have an array, we pass in the callback, which returns true or false for include or filter out this element. We start off with an empty array, and then we go through all the elements in the array passed in, and we call this callback on each element, and if it returns true, we just push the element onto the new array and we return the new array. And here's the callback code, really simple. If we divide the element by 2, if the remainder is 0, it's even. If it's not, it's odd. And let's just run it. Bingo. It's filtered out the odd elements and just returned an array with the even elements. So here we are, filter with loop. That's the original array. That's our callback function. We're going to get another array, which is this even elements array. This array hasn't been changed at all. It'll be exactly the same values in this particular array. So we get another array with just the even elements. Now, time for some fun. We have a new function called reduce. Let's use that instead. Now, in doing so, I do want to keep the original signature of this callback function. I don't want to have, as we had in reduce earlier on, I don't want to have this bizarre looking parameter or argument. I just want to be able to say, here's an element, return whether it's even or not. So we're going to have to somehow convert this small, easily understood function into another function that I can use with reduce. Now to do this, I'm going to make use of a helper function that, given this kind of callback, is going to return a function that can be can be used by reduce. So let's go to this example. Now, the awkwardly named make filter callback for reduce takes a simple callback, and it's going to return another function of the right type or the right syntax so that reduce can use it. So we assume that value is going to be the resulting array, and here's the current element of the array that we're walking through. So if the function returns true, we're going to push the new element onto this value array and return the value array. So notice what's happening here. This new function calls the original callback. It has no name, this function. It's just an object at this point. I'm going to assign it to something else. I'm going to assign it to a variable. I'm going to assign it to an argument. And this is the other part, if you like, of functional programming. I talked about passing functions into another function, which is essentially what we're doing here and what we've been doing up to now. We're passing a function into another function. But this one is actually going to return yet another function of the right type for us to use. Now, one of the important things to take away here also is that the make filter callback for reduce function makes use of a closure to contain this original callback. Now, once the maker function returns with a new function, that new function will still have a reference to the fn parameter and can still use it. I mean, after all, here's the new function I'm returning here, and it has to be able to use this fn parameter which is passed in here. This is done through a closure. Closure is the language's way of encapsulating some local data created within a function that returns another function. The returned function still has access to that local data. One way of thinking about it is that the language creates a private invocation object that is parceled along with the newly returned function for its use. And note the return value doesn't have to just be a function. It could be an object with methods. Those methods are also returned functions in a sense, and a closure would still apply. Closures, along with immutability, are of prime importance with functional JavaScript. And by the way, here we go. Here's the filter function. I'm declaring here it takes an array and a callback. This returns either true or false, and we're going to call internally, we're going to call reduce on the array. This is the first parameter to the reduce function, and it's going to be the result of calling make filter callback for reduce on our simple callback. And here's the initial value that we're passing in to reduce. In this case, we're passing in an empty array. Reduce doesn't care what the original value is. It just expects the callback to do the right thing, if you like, with the value passed in. And here's my little callback, easy peasy. And so let's just run it, and lo and behold, it works. We're filtering numArray with the isEven callback, getting the even elements, and I'm just logging that. Now, filter, this function up here, is also a method now defined on the array prototype in JavaScript. In fact, pretty much you never need to write a for loop with an array ever again with functional JavaScript. JavaScript now contains on the array prototype a bunch of methods to allow you to process all the elements in an array in some fashion. So we have for each, for example, on all the elements of an array. We have reduce, as you saw, which reduces the elements of an array into a single value. We have filter, which filters out elements. And here's another one, another example. So often there's a scenario where, given an array, there is a need to create another array whose elements are calculated from the elements in the original array. So let's say, for example, the original array is an array of objects, and one of the properties of those objects is called ID, and you need to create an array of IDs. So here's an example. We have an object array. It's a set of 6 objects. Each object has one property, because I couldn't be bothered to type anymore, and that property is an ID property, and this is 1, 2, 3, 4, 5, 6. And what we're going to do is we're assuming there's going to be a pure function, the mapping function, that takes in an element of the original array and returns an element for the new array. And this kind of functionality is called map, as you can see here. You're mapping the elements of one array to produce another. Now let's see how to code that one up with reduce. So again, the function, the callback function, is going to be pretty simple. Here it is, in fact, here's my callback function. Given an element, it's going to return the element ID. That's it. So again, we have to convert this into another type of function so that reduce can use it. And here's that function, the make map callback for reduce function. Takes in a simple, here's an element, give me the result out of that. And again, we do pretty much exactly what we did for filter. So we take the value, we're going to assume it's an array, we're going to push the result of calling our callback function on the current element. And we're going to return the new array to reduce. And again, here we are, array.reduce, here's the array, array.reduce. Convert the callback function into something reduce can use, start off with the empty array, it's going to return the full array, and let's run it. So here's my original object array, I haven't modified it, it's immutable, and all I've done is extract out the ID values into another array, and we get that value here. Now, notice, as you probably have seen, I haven't declared the mapping function as a separately named function. I've just passed it in as the argument to this map function. So this is going to become fn up here. Now, this kind of speaks to the notion I stated earlier. Small functions, well named, help produce self-documenting code. Now, in this case, I'd have to say having the mapping function inserted into the actual call itself does nothing for readability. There's so much infrastructure stuff going on around the actual code. I mean, all the code needs to do is return this value, element.id. And it all gets lost in these braces. We have this weird brace closed parenthesis at the end because it's, it's the end of the call here, and this is the end of this function here, and then we have the word function and return and so on and so forth. Yeah, this is a very simple example. But wouldn't it be easier to maybe have this, for example? Oh, by the way, I meant to add, map is also now a function or a method on the array prototype, so it's available for all arrays. So I could actually now change this to IDs equals obj array dot map, open parentheses, this wacky weird function here, and close. And lo and behold, it still works. I don't know about you, but I can understand what this is doing. It's a separate function. I can test it separately. I can read it and just say, okay, get ID. I understand what get ID does, and then have this line of code, and I understand, oh, get ID just returns the ID of the current element. It's one of those things. It's a small point, but sometimes it can be better to buck this trend of declaring functions in function calls and then separate them out entirely. Here's another example which may or may not be easier to read in the future. This is the ECMAScript 6 version of this. What we're doing here is we are going to be using the so-called fat arrow or lambda expression here. We're mapping an element onto its element ID, and that's what's going to be returned. This, I don't know, this is more legible to me than this original code up here. So I think in ECMAScript 6 with fat arrows, it's going to be a lot easier to write this kind of code in one line. Maybe, maybe not. Just like to restate that this ES6 type syntax is slowly being incorporated into modern browsers. It just so happens in this particular case, JavaScript JSLint knows about the fat arrow, so it's not complaining about this weird language here. And the other one is, let me just copy this again. Whoops, just this line. And the nice thing about it is Node actually understands about the fat arrow too. So if I now run this, I'm running it with Node. The second one here is the one I've just added. So it also understands about the fat arrow. So Node understands about it. Firefox understands about it. Chrome does. The fat arrow is already there in Edge, Chrome, and Firefox, as you saw, Node.js. But other aspects of ECMAScript 6 are still being introduced. But of course, that doesn't solve the issue of your users having older browsers, but you can always compile ES6 syntax code down to ES5 or JavaScript 5 as part of your build process. The compiler, quote unquote, to use there is Babel, babel.js, B-A-B-E-L. Anyway, map is currently part of the array. Now, I'm going to switch over to another aspect of functional programming, and that's currying, or less strictly, partial application. Currying is especially important in those languages that only allow for one parameter per function. Yes, they exist. If you want to write a function that accepts several arguments, for example 3, you have to essentially decompose that function into several simpler functions. The first function accepts the first parameter, constructs another function that takes in the second parameter, which in turn creates a function that consumes the third parameter and which returns the result. To be honest, I've never found a need for currying when writing JavaScript, so forget about it. Don't use it. It's fun. You can be academic if you want to be. You can infer some things about the lambda calculus with currying. It's named after a guy called Curry. Forget it. Partial application, on the other hand, used all the time. Let's use this, introduce this with a simple example as before. Now, I'm sure you're all familiar with the set timeout function. It delays execution of some code for a delay a certain period of time. Let's suppose you're writing some code and you notice that you're pretty much always using a delay of 10 milliseconds. You may think that's weird, but it's a recognized technique for splitting up long-running code to allow the rest of the application to, if you like, breathe. You don't get the weird dialogue coming up in your browser saying, this script is taking a very long time to execute. Do you want to cancel? and all that kind of stuff. If you split up your code with a delay of 10 milliseconds, which is instantaneous essentially, it stops that weird stuff happening. So to save time, you quickly write a simple function called delay 10 milliseconds. And all delay 10 milliseconds does, accepts a function to execute, calls set timeout with that function and 10 milliseconds. Brilliant. Fantastic. It works. I think. Yeah. So here's the before the short delay. We set the short delay, and then 10 milliseconds later we get this console log after the short delay. So we can see it's actually executing properly. Then you find yourself writing delays of 3 seconds. Now these would be presumably used to remove some informational content after displaying it as some element on your web page to the user. So you go ahead and you write another function called, let's say delay 3 seconds. And we're going to delay 3 seconds. And let's make sure we're, it's a long delay after the long delay, oops, and after the long delay. Brilliant. We can now execute that. So notice how the delayed stuff occurs afterwards. So we call before the short delay, we set it. Before the long delay, we set it. The short delay happens first, the long delay happens afterwards. And we finish in 0.3 seconds. It should be like 3 seconds. Not quite sure what's going on there. Anyway. But just notice what I did. I copy and pasted this function. Yeah, it's only set timeout, so I didn't even need the function at all, but I'm just using this as a very simple example. So what am I going to do to resolve that? I'm going to write a function that makes another delay function. So I'm going to write a function. It's going to be called make delayer. Make delayer. And it's going to accept a function. And within that, it's going to return another function, which, oh, no, make delay is going to accept a delay time. And it's going to return another function, which has to accept the function to execute after the delay actually happens. So set timeout, fn, comma, delay time. What I've done here is I've created this, we're creating a function returns another function, but what I'm doing, if you like, essentially is I'm pre-populating a parameter or argument of the array in this returned array. So here I have var delay, 10 milliseconds, version 2 is equal to make delayer for 10. Whoops. And then, whoops, I didn't want to do that either. And here, another function here. So delay 3 seconds, make delayer 3000. So I now have two separate functions which do what they're supposed to do, but what's actually happening is I am presetting the delay time to a particular value. This is called partial application. So when I call delay ms2, for example, in exactly the same way as up here, let's just do it for this, bring it down. So in exactly the same way here, this function will be delayed by 10 milliseconds because I am pre-filling the second parameter of this call. Here's another simpler example perhaps. Well, what I've got here is you want to be able to log debug values from the console in several places in your code. You want to differentiate where these logs come from by prefixing them with a descriptive string. So pretty easy stuff. Here's some debug values you want to report on. They're going to get modified during the course of the application. And here I am somewhere in my code. I'm going to have a console log. It's presumably going to be in a non-click handler, and I want to look at debug values.string, and here's another example of something that can be called. And if I run this, well, look at this, it actually works. But I find that I'm actually copying this code in several different places. So again, you find yourself copying and pasting, same descriptive strings, same way of calling console.log. So it's time to refactor. So let's make a make logger function here. Here we have a make logger function. It takes an ID string. It does a little bit of weird stuff here to make sure the ID string ends with a colon. Makes it easier to read on the end, and then it returns a function that does this wacky, weird, wonderful stuff. Now, the problem is console.log accepts any number of arguments. It doesn't matter. It can accept more than one parameter. So in examples above, I was actually using two. So I was using, this is the first parameter, and this is the second parameter. And as you see, all that happens with console.log is it just puts a space in between the values. So you have to do a little bit of extra weird and wacky work to convert the arguments pseudo array, this thing here, into a real array, which is what this is happening here. It gets converted into a real array, and then I'm prepending it with the ID value to make another array. I'm calling that args, and then I have to call the apply method of console.log. Apply is a property of the function prototype, which basically says, call this function, this first parameter is this value, and the second parameter is all of the other arguments. So this is weird and wacky, but that's just the way that console.log works. It accepts any number of arguments, so we have to do this weird stuff. But before, there's nothing really I can do about that, but look at this other code up here. It fiddles with the ID string in some way. It takes a little bit of time for you to parse it and understand what's going on. Functional programming, it teaches us to use small, descriptive, easily tested functions. So let's quickly refactor this. Oh, here's how to make it. Let's make sure it actually works. I forgot I added this bit in. So yes, here we go. So my on-click logger is actually going to ask me to, to display two values, and it does, but it prepends it with the word on click, and on this one, the Ajax logger just wants to look at one value, and here it is. So you can see it does work. So yeah, it looks a bit kind of, yeah, you can read it, but it's a bit messy. Let's refactor it so that we can make something slightly better. The first thing I'm going to do is, let's create a function which returns the last character of a string. So it has a string, and all it's going to do is return the last character, which is using this weird thing called char at, and oops, -1, and that's all it does. So automatically we slightly made it slightly easier. This is nothing or last char of ID. Now what this code is doing is it's saying, well, if the last character is not this thing, then make it that thing. Or suffix it with this colon thing. So let's extract that out into yet another function. So let's say ensure last car. We're given a string, we're given a character, and what we need to do is roughly this. Copy, actually no, I'm going to return. So if the last character of the string is equal to C, then, whoops, return the string itself, I don't care, or return the string plus C. So now I can replace this with ensure last character ID and colon. Couple of things here. A, this is easier to read because A, I've named it something reasonable, last character. Oh, yeah, I understand it's going to get the last character of a string. Yeah, this is a little more complicated to read, but at least I can believe and understand and test that last char of a string returns the last character. And this one makes it more applicable in different cases. I don't care that it's an ID string or anything like that. I don't care that this is the colon character or anything like that. All I'm saying is, given a string, make sure the last character, return a string with the last character to be whatever C is. And again, more testable, it's more legible, and it also doesn't work because, yes, I did this last time. This should be S, and this should be S. If I'd actually saved it, it would have told me. But anyway, so again, it works. But here we've made it slightly easier to read. You know, if I wanted to change this to, I don't know, it doesn't make sense to have anything else. Maybe it'll still work. And it didn't, because that is an important thing in save, build. There we go. Okay, I'm not quite sure why that isn't working now, but nevertheless, I am not doing something properly. Return those characters S equals C, S plus C. Or
joys of coding live, Julian.
Yes, I know, because I'm doing something wrong.
We are at the hour, but a couple of things I just wanted to call out. You mentioned before that the ECMAScript 6 standards, or there is a website that shows what is and is not implemented in current browsers. Do you have that handy?
No, I don't. You gave it to me yesterday, but
let's go. We'll put that up on a tweet or a post. It's just useful to know exactly what is already covered by what browsers, and also just to iterate the fact that you mentioned in order to compile some of those things, I especially like the use of the fat arrow and the nicer looking code at that point. So you said that Babel was the tool to use there.
Yep, babel.js. In fact, hang on, I'll show you. Babel.js. Boom. And here we are. Oops. Babeljs.io, in fact.
Excellent.
So
that's just going to allow you to get use of all the cool new stuff, but still have backwards compatibility on your browser.
Exactly. So in summary then, the kind of goals you should aim for with functional programming is write readable self-documenting code. In other words, small functions, well-named functions. Don't worry about your having lots and lots of small functions. The browser's interpreter or compiler will inline functions if they're small enough. So you're not necessarily, what's the word, losing time by calling a function and having to return from the function. They'll be inlined. Look for refactoring opportunities for using partial application, as I showed, or hiding weird-looking code behind a simple name. Aim for immutability all over. It just makes it easier to test functions, and there we go. Learn about lambda expressions, the fat arrow. It'll help you write inline functions being passed to arguments of other functions. So were there any questions? A
couple of people were pointing out some quick typos, but you figured most of that out.
Okay.
And of course, functional JavaScript, it's pretty insane, especially knowing that a lot of that stuff's now been built in, but it is always good just to see what is happening in that. So,
okay.
Of course, we're back in DevExtreme land next week.
And DevExtreme indeed. We're going to be talking about, debugging on a device.
Yeah.
It's all very well, debugging in an emulator and all that kind of stuff, but, once you compile an application with PhoneGap or Cordova and put it on a device and it goes wrong, what do you do then? So, with that, I think we can pass over to Amanda. If you have any questions, I'd love to hear them. There's my details, julianb@devexpress.com. I'm on Twitter at jmbucknell. You can also send emails to Paul, and paulu at devexpress.com. At DX Australia is his Twitter account, and we'll be happy to help you out. Amanda.
Awesome. Thank you, guys. All right, everybody, check out devexpress.com/webinars for all upcoming webinars, and you can access previously recorded webinar sessions. And like I mentioned previously, today's webinar will also be available later on our DevExpress YouTube channel. The link is posted in the chat box. And that is it for this one. Thank you so much to Julian and Paul. Thank you all for joining us. And of course, thank you for choosing DevExpress. Bye-bye.